We will now look at the second use of the velocity equation. This would be problem 2, which was left as blank in the general collision. Notice it's problem 2. We don't start with the velocity equation. So it can be used if we know the collision is elastic, perfectly elastic, and we need a second equation to actually get the answers somewhere in the problem. Maybe both after collision or any two of the four velocities in the problem based on given information. The other time we can use the perfectly elastic equation is once we already have all the velocities to check if the equation or if the collision is perfectly elastic. So what we're going to do for number 2 is check to see if the general collision could have been perfectly elastic. There is only one way to check, and that's by using this. So making sure we know this would have been the general collision. Was the collision perfectly elastic? Well, we'll use this equation and check it. We'll write it like this. V1 initial plus V1 final. Is it equal to V2 final plus V2 initial? So let's put numbers in. V1 initial, so we have 0.250 meters per second, plus V1 final, which we found as 0.100 meter per second. Is it equal to V2 final, which was given as 0.125 meters per second, plus V2 initial, which was negative 0.100 meter per second. So what this says, 0.350 meters per second is not equal to 0.025 meters per second. So make sure you make a statement to say, no, not perfectly elastic. Don't just leave it as not equal. When you're checking something, you do need to make a statement so I know, or anybody reading the problem knows, that because they are unequal, the collision is not perfectly elastic. Again, notice this was the second equation. We used it after we had answers to check. Never start a problem with the perfectly elastic equation.